It's just a matter of units, and at theoretical levels, they're more concerned with the general concept and not the units themselves. So I think everyone's heard of the famous E equals mc squared. Well, in naturalized units, you just write E equals m. Having done more on the experimental side than on the theoretical side, something just seems wrong about that, but if you ever see E equals m, they're using naturalized units. All right, so my mass is about 100 kilograms. Let's see, what do we got in here? I'm gonna guess one of you is probably half my weight. Let's assume that one of you is average adult, 70 kilograms. Distance, Michael, I'm gonna make you average. 4 meters? So the magnitude of the force due to gravity is that. Someone be kind enough to crank that out.
I got 0.000000029 newtons.
How many zeros was that?
7.
And then 29?
2918.
Yeah, I got 2.91 e to the negative 8.
Yep. Units? So that would be the gravitational pull between us, which is why when we were doing force diagrams, we ignore it. Because I think I can safely say that the force between me and the Earth is around 1,000 newtons. The force between me and Michael is not worth mentioning. 29 nanonewtons.
Still bigger than I thought it would be.
Oh. Make it bigger, just make it closer. It's now 4 times bigger. If I went half the distance.
Right.
All right. So obviously, looking at this formula doesn't make a whole lot of sense if you can use mg. So let's do mg. Let's find the force due to gravity between me and the Earth using that formula. So the force due to gravity, the magnitude would be 6.67 times 10 to the negative 11 times 100, my mass, times the Earth, 5.98 times 10 to the 24th, divided by, what distance should I pick? Double check that radius. No, let me double check the mass. Yes, right? The book says 9736. What distance should I pick?
Well, it would be your distance to the center of the Earth, right?
Yes.
But in this case, we don't really know that.
Well, it's going to be roughly 6.3. I want to go 6.38, but today 378 times 10 to the 6th meters. And we should end up with something around 1,000, 980, somewhere in there.
979.47.
And if we did it the shorter way and just did mg, we'd have 100 times 9.798 or 179.8 newtons. So pretty darn close both ways. However, much simpler if you know the value of little g. But obviously there is something missing here. What is missing? We're talking about a force.
Direction.
Say it again?
Direction.
Yes. And so my formula right here, since I have a vector here, I need to have some sort of vector on this side, and it is towards the center of the other object. So the force on me is towards the center of the Earth. So negative R2 hat, let's do that. Let's clear this and get a little space. So the force of gravity on object 1 from object 2. So this is the force on 1 from 2. Negative G, mass 1, mass 2 over R squared times R2 hat. So the force on 1, the value you're going to get is relative to mass 2. The negative just means it's towards. So that's supposed to go away. And on that note, now that you're all pumped up, it's time for you to go out into the world and make everyone else understand the beauty of physics. Or, go home, eat dinner. Whatever you're into.
Oh, I had stuff to I have